So why would it want you to find tangent theta?
Yeah, I don't.
Is
Well,
that for a
so
specific reason, or is it just
well, so okay. Let's just start with this. Let's just say here's the more standard problem, and I guess I'll give you all the because I think this is what you're asking. Um, so if I give you two vectors, u and v, okay, and u, is some, 1, 2, 3, and v is 4, 5, and 6. You can find the angle between them using that formula we just talked about.
right?
Okay. But if I'm an instructor, and I've seen it this way, I've seen it where they give you the angle, but they don't give you one of these values. They say like it's A or it's 2A. And then you have to solve for it. So they'll tell you like theta is 45. And then you know that the cosine of 45 is the square root of 2 over 2, things like that. Alternatively, if you use this to find theta, I mean, it's reasonable for me to ask you like, secant of theta, which is the reciprocal of this thing. So they're just sort of like giving you like variations on the same problem.
Right.
After you find
I've noticed that in all these homeworks that that's like every question is just like a variations of itself.
Yeah. Now the question I would be asking is your homework gonna, I'm sorry, is your exam gonna look like these? Will she just grab?
I have no idea. None of us have any idea.
Yeah.
We don't even have a review.
So at Arizona State University, they give exams that are exactly like the web work questions. And at the University of Arizona, they sometimes pull the web assigned questions, which are the same as web work questions, and they just print them on, paper. And that's where, it's where you'll know so much after you go in there. Yeah. I mean,
but she hasn't told us any, like we're going in pretty much blind, to be honest.
Yeah. Yeah. And this is a tough class. This is a really tough class because you're doing.
I've heard people say that my teacher, her tests are easy, but I've also heard that they're not. So I don't know. I guess we'll find out.
So I know that answers your question fully, but like there's no value in tangent of theta or cosine of theta. It's just like something to do with this, but it'll say find the angle between two vectors. It won't give you the formula. You'll have to know it.
So if it asks for tangent, just flip it, pretty much.
Tangent's the cross product over the dot product.
Oh, okay.
Magnitude, the magnitude of the cross product.
Okay.
And I actually like that one because then you got to do a cross product.
Right.
But there's a separate question for that usually.
Okay.
Okay. So,
this one I don't know how to tell.
So the easier one is perpendicular. So they're perpendicular if the dot product is 0.
Okay.
So that's usually where you start. You first you're like, I wonder if it's 0. So in your problem, it's -2, 5 dotted with 13, -28, -6. Do you know if you're allowed to use a calculator on this exam?
We are not.
Okay. So you won't get, you wouldn't get numbers near this large, but -26, +56, and -30, and that does equal 0. So you always start with that. Okay. Now, the kind of the harder one here, but it is next, is are they parallel? And they're parallel if it's a scalar multiple. And I don't even like that wording, but it's like k times your vector, which k could be positive, negative, it could be a fraction, if that equals this other, other thing. So like you're like, well, -2 times what gets you to 4? You think, well, maybe it's k equals -2. It's got to work for all of them. And that's why that one works here. The next one, that's where it's a little bit, how do you go from -2 to -3? Well, you multiply by 3/2. And does it work for the other ones? Yeah, it does. Okay. So then the third, and this is the path you want to take. You want to first hope they're perpendicular. Dot product is 0, parallel, scalar multiple. 3 is everything else. So it's more like, well, it's not perpendicular and they're not parallel, therefore they're neither.
Okay.
So the question, let me see if I can pull it up here really quick. because I think this would be useful. There's kind of a traditional question where they ask, what value of K do they give you to make them, parallel or perpendicular? And of course I can't find it. I guess not. Okay, so the more likely question is they I should pull it up. Let me pull this one up. It just need 30 more seconds to find it. It's a good question for us to do. All right, sorry, I'm not finding it. But it is this. It's one of these dot product questions. Let me just keep going on yours, and I'll look it up here in a bit. All right, so next question here. So the suppose you're given a U and then they give you another angle and they want to, probably the other option here was an acute angle, right?
Mhm.
2 sub 2 or acute.
Yep.
So let's look at the right angle. So the right angle is when so if you go back to your cosine of theta equals U dot V over magnitude U magnitude V. So if you remember on the unit circle, when theta is 0, okay, cosine of 0 is 1. At 90 degrees, the cosine of 90 degrees is 0. That's the x value. So if the dot product equals 0, then it's 90 degrees.
Okay.
Okay, so but I mean, I'm struggling here a little bit. If you got 2 comma 0 comma 3 dotted with 2 comma minus 3 comma minus 2, that dot product is 4 plus 0 minus 6. That one's not. Are you sure this is right?
I can double check. Pretty sure, but which one are these? Is this the dot product homework?
It didn't. This is all I got. This is all
Oh,
you
okay.
sent me. So no, I'm sorry. Cross product problem 10.
Okay.
Oh yeah, you're at 0% on this. Okay, that's why. Yeah, no, this one is not a
I
right
did not
angle.
get it right. Okay.
Okay, so is there one here that does make a right angle? Yes. So so this third one does.
Okay.
Okay, so if we have, and look at this, if we have 2 comma 0 comma 3 dotted with minus 6 comma 0 comma 4, okay, so when you do the dot product here, it's negative 12 plus 0 plus 12, that's 0, and that's how you know. So there's a lot of flashcards here. So if the dot product is 0,
Mhm.
you know that it's a 90-degree angle
Okay.
that's made with them.
Okay.
All right. Now, in terms of like whether it's acute or obtuse,
Mhm.
so you can do a couple of things here. So notice how the denominator is always positive.
Right.
So what you remember from your trig class is this ASTC thing. So cosine theta, because the angles are always made here, and this is kind of a shortcut, if U dot V is positive, it's going to be an acute angle. But if U dot V is negative, it's going to be an obtuse angle
Okay.
because it's in the second quadrant. Now, I probably would still check that it's the full get the full angle and make sure that it's what I think it is. But you're
Right.
not going to, you're not even have a calculator. So
Right.
you're not going to be doing that. So you are truly going to get something like this, where it's like, if you know these certain relationships, like at 90 degrees, it's 0.
Right.
You know, the other one that's harder to do is where it's 180 degrees, where they're completely opposite of each other.
Mhm.
But you can actually detect that from the formula. So if everything is in the opposite direction on you, then they're 180 degrees apart. But so you're not gonna be able to use a calculator, so you won't even be able to tell this. Well, you can use this trick of the negative and positive, though, I guess, to do it.
Mhm. Okay, I see. I didn't know that little trick.
Yeah. Okay. Can I move to a new question?
Yes.
Okay. Find a unit vector in the same direction as v. So the unit vector, the thing that's really important about the unit vector is that the unit vector, its magnitude is 1.
Right.
So the recipe here is you take your vector and you divide it by the magnitude of itself. So your vector is 3, 4, minus 3, and its magnitude is 3 squared plus 4 squared plus minus 3 squared square rooted. Okay, so on the bottom here, 9, 16, 25. So you got square root of 34, like that. And like, this is correct. Now, would an instructor accept this? You're really supposed to rationalize and things like that. So you're first supposed to take each component and divide it by the square root of 34.
Yeah, that's what I'll do on a test.
Yeah.
This
And
was not
then,
work, so I just use my calculator.
yeah, and I think it's great, but even this is not quite right, because you're supposed to rationalize. It'd be 3 square root 34 over 34, 4 square root 34 over 34,
Okay.
and so on.
So you think I should do it that way instead?
I definitely would, but may not have time. There's a lot of issues there.
So is it, if it were asking in the opposite direction, would I just flip the signs of everything?
Opposite direction.
Yes.
Oh yeah. Sometimes it does. You're right. Sometimes it does ask for that. Find a unit vector in the opposite direction as v.
So the first two would be negative, and then the third one would be positive.
You would, yeah, because you would actually just divide by the negative magnitude, which does exactly what you said. It changes the sign of 3 to -3, 4 to -4, and -3 to +3.
Okay. Cool.
So actually, here, this question, this next question, we sort of already answered, because let me snip it in here. We've already talked about how you use the dot product to figure out if the angle between is acute, obtuse, or right.
Oh, okay.
So the dot product is 6, it's positive. And that tells you that, it's positive in the first quadrant, which is acute, and it's negative in the second quadrant, where it's obtuse. If the dot product were 0, that's where you know it was 90.
Right. Okay, sweet.
All right, I don't know if you sent more questions. If you did, they didn't upload, so let me just check on that.
I did send
Oh, you sent 6 or
I sent 9.
9. Okay. Let's just see here why they're not uploading. Maybe they did. I just refreshed this. Okay. There they are. Okay, so that's make sure we got all those. Okay, yeah. All right, so here we go. You just asked me about this.
I have more questions that I could send.
Yeah.
These are the base ones that I wanted to start out with.
Okay. This is find a unit vector in the direction opposite of that.
Okay.
So, and,
Yeah.
sometimes entering it in here is kind of annoying, but yeah, you got it. You score that, score that, score that. All right, next one here. is snip it in. All right, if A, B, and PQ are parallel, do they point in the same direction? So I guess I'm taking that to mean like one goes that way and one goes that way, but they could alternatively go in opposite directions.
Right.
What I guess I don't even understand. Like, was there something else in the drop down here?
Which problem was this? If I sent it.
It does not show, but nevertheless, so we can find AB. So to find AB, we take the X components and subtract them. So we have -5, minus a -3, comma -3, minus a -4. That gives you -2, comma 1. And then we can do the same thing for PQ. We take the second one and subtract. So we got -4 minus 2, comma 4 minus 1. So that becomes -6, comma 3. And the idea here is that there's a K between these two. There's a K of 3 that matches them. So if you multiply -2 by 3 and 1 by 3, you get that. So that tells you that they're parallel. It furthermore tells you they're not in the same, well, they are in the same direction because they're the same sign. If this was like 6 and -3, then it would be in the opposite direction.
Okay.
But it does look like you have to compute these, and this is stuff you can do by hand. This would be fair
Right.
game on a test.
Right. I just didn't know how to tell if they were parallel. Yeah, I just didn't know how to. The K thing. I don't remember her saying that, but I
Well,
could.
K is something I'm using. You can, they call it a scalar multiple.
Oh, okay.
Maybe C is more commonly used.
Okay. Is that all the problems I sent you?
Nope, there's one more. There's one on planes.
All right. Yeah, I just didn't know how to. I didn't know how to tell. I couldn't visualize. I have trouble visualizing it.
Yeah, you and me both. I definitely stink at this.
Was that this semester, even in physics? Last semester I could visualize everything, but
Yeah,
this
well, it's like
semester,
physics, probably like, well, an electron and insulating surface, and you're like,
yeah,
what does that even?
it's just stuff I can't see. So
All right, I think the easier ones are the last 3 here. So in 3 space, you have X and Y and Z. Okay, and they're saying that Z is always 6. So imagine that that's 6, but X and Y can go in any direction that they want.
mhm.
So you can see that it's a plane. Z equals 6. I'm sorry, I wasn't clear. We're starting with that one.
Okay.
So Z equals 6 is a plane because it's at 6, and you can go any direction you want from there.
Okay.
Now
But you can't go down.
no, because and we tend to think of Z as being up or down. So you're just flat
Okay.
surface, like you're in Iowa and you're just flat forever. Okay. So that's B. Now Y equals 9, and you kind of have to redraw these each time. X, Y. So Y is 9 is you're here. There's 9, and you can now go up or down, right and left. Okay, but you can't go in this Y direction. So it's yet another plane. This one appears to be vertical, I guess.
Or we have the X and the Y split. X is our forward and backwards.
Yeah, you're right. Sorry, it's really bad. So that will change this slightly. Okay. Yeah, right hand rule, X swings to Y, Z is straight up. Here's Y equals 9. But you can go X, you can go in the X direction as far as you want, and you can go in the Y direction. So I found that it's helpful to sort of draw these sheets of paper.
Okay.
So it is yet another vertical plane for Y equals 9.
Okay. So it can go up or down, up or down,
Up or
forward,
down.
backward, but it can't go left to right.
That's right. Yeah.
Okay.
And then the last one, X equals 4. It's probably good to see all these. It's the one I just did. Let me rotate this, move this slightly. So X, Y, and Z. So X equals 4. You can go left, right, I guess. I don't know. That's a little odd. And you can go up and down. But to me, that's another vertical plane.
Okay. Okay, that makes sense.
Okay, so now the last one, I'm gonna go to Wolfram. There are a few 3D plotters out there that I think are really helpful. 6x plus 7y. Plus 6x plus 7y plus 6. Yeah, okay, so let me see if I can grab the snip of this. Yeah, it really is. I think this is the hardest part of the course, is these visualizations.
Right.
And you're going to do contour plots and some other things that are hard to see. So like I could have told you that it's a plane because of it's of the form AX plus BY equals C. Okay. But I don't know what it looks like. And if you're asked to draw these, do you think there's a chance you're gonna have to draw these?
Ooh, I doubt it.
Have you? Yeah, because
Because
did she do any of that in class?
she draws it, but I highly doubt that she'll
Okay.
make it draw it.
Okay. So you can see this is a plane. I mean, it's a sheet of paper, and this form always is a plane. So whenever one of the variables are free or missing, like here's, I mean, AZ plus BY equals C is also a plane. And so is AY plus BZ equals C. That's also a plane.
Okay.
But it's neither horizontal or vertical.
What do you mean?
Well, it's not like it. So when in the previous ones, there were two variables that were able to move. So you got this nice vertical
Right.
sheets, and horizontal. But in this one, it's sort of angled. I don't know if you can see that. It's angled.
Okay. Yeah, I see that.
Okay, that is everything you sent me. I can pull up a quiz on some dot products and cross product stuff if you would like, if you need.
That'll work.
See if I can find some more stuff here for you.
Also, I scheduled tomorrow's appointment just in case.
Okay.
I might not even be I might cancel it.
Okay.
Is there like a
Let's do this. Just wait and see. And
okay.
I'm not super busy usually during that time. We can just reschedule it for another day down the road.
Okay.
Okay, so here is a question. This is on like a practice exam.
Yeah, I wish he gave us a review at least, so we have some idea what to expect.
Yeah. All right. I'll help clean this up here. But here is so W. Let's see. You need W. So W is I minus 3J plus 2K, and V is 5I plus J minus K. And it wants 3V dot W. So how would you go about doing this?
You'd multiply all of V times 3.
Okay. So 3V would be 15I plus 3J minus 3K. And now you got to dot that. I sometimes dot it vertically. I find sometimes that's useful. I minus 3J plus 2K. So I just multiply vertically here. So like 15 minus 9 minus 6, which is 0.
Better.
So what does that mean when the dot product is 0? What does that tell you about the angle between them? Sorry, that's not right. 3V dot W equals 0.
The angle between it is 90 degrees.
Yep, so theta is 90 degrees. Fantastic. Okay, so the next question here wants a unit vector in the direction of V. So let's go back and grab V. How do you find the unit vector in the direction of V?
Yeah. You do the vector you have divided by the length of the vector.
Yes. So the magnitude of this vector is 5 squared plus 1 squared plus -1 squared square rooted. Okay, so that's the square root of 27. So it's 5 over the square root of 27 plus, that's I, plus 1 over the square root of 27j minus 1 over the square root of 27k. And then maybe not, you could rationalize that if you wanted.
What's the point of doing that? Like, what is it? Is it just simplifying it further?
Yeah, so yes, use it in the next chapter to find equations of planes and stuff. But yeah, it's like easier to express things in terms of its normal vector.
Right. Yeah, I remember normal vector.
Yeah, it's not a great explanation. I think it's for compactness. So, okay. This is probably the most interesting question here. It says the value of M making U and V parallel. So U is minus 2I hat plus 2M minus 1J hat minus 4K hat. And then a W, get W here. W is I hat minus 3J hat plus 2K hat. So what you want to do is set the if M is in more than one place, but you create a system of equations. So 2M minus 1 equals minus 3, and then you solve for M.
Okay. And that's it.
That is it.
Oh, okay.
Have you done anything with triangles?
Yes.
All right, so here we go. This is another good question for us to look at. Consider triangle ABC, where A is the point 4, 5, minus 3, B is the point 0, minus 3, 2, and C is the point 4, 1, 1. So now it wants you to find a vector normal to the triangle. This is a little weird. Like this triangle is in some sort of 3 space like that. It's kind of like a Star Wars ship. The normal vector sits right in the middle of it and points up. Okay. And like, I don't know, that's weird. I don't really know what to make of that, but that's what it is. So to actually find it, you need, like, let's say this is A and this is B and this is C. You need A to B and you need A to C. So you have to find these 2 vectors that enclose the triangle.
Right.
Okay, so to find A and B, you just do some subtracting. So that AB is going to be 0 minus 4, comma, minus 3 minus 5, 2 minus a minus 3. Okay, so that's minus 4, minus 8, and 5. Okay. And then we do the same thing for for AC. Did you do this in class, or is this totally foreign to you?
No, we've done this.
Okay, 4 minus 4, 1 minus 5, and 1 minus a minus 3. So that gets you to 0, minus 4, and 4. Okay, now there's a couple of ways to do cross product, which is what we need to do next. So to get a normal vector, you have to use cross product.
Okay.
Okay, so the way that I prefer to do cross product is through a determinant of a matrix. Hopefully you
Right.
saw that. So I like to, because you actually end up using this later in the course when you find gradients and other things. So
Okay.
the order matters. Minus 4 minus, because there's actually 2 normal vectors. So there's that one, and then there's the one that goes down. And then you got 0, minus 4, 4. And again, these are my preferences. So I like to write I first, and then you're multiplying minus 8 times minus 4.
Yep.
Minus 5 times minus 4, which is negative 20. Minus j hat. Don't forget to change the sign there. And so you're ignoring this one. Minus 4 times 4 is minus 16. 5 times 0 is 0. Plus k hat, which is minus 16 minus 0 again. And then I can nicely write it as minus 12 I hat plus 16 j hat plus 6 k hat. That's the normal vector. Now sometimes they throw in the word, it'll say unit vector, unit
Right.
normal vector, and then you gotta normalize this thing.
Yeah.
It's tough,
Yeah.
tough on this.
We've seen that before.
Okay, and then just to kind of make matters worse, part B here, they want the area of the triangle. Like I feel like this is a very stock calculus 3 question. What is the area of the triangle?
Right.
And so the area of a triangle is a formula. It's 1/2 the magnitude of the cross product. So for us, that's AB cross AC. So you see, you don't get away from finding the magnitude of this thing. So the magnitude of this thing is minus 12 squared plus 16 squared plus 6 squared square rooted. Now,
You said these problems we're doing, it's a quiz or a practice exam?
this is a practice exam, or this is a practice exam.
Okay, cool.
Does it look familiar to you or something?
Yeah. No, I was just wondering if like these are questions that would be on it.
Yeah, the people, I've got a lot of source material,
Okay.
but not all that's useful for what we're doing.
'Cause these are, I feel like these are problems that would definitely be on the exam.
All right, let me see if I can find this other one.
Or these variations of them, obviously.
Yeah. Why isn't it there? Oh, there it is. Okay. Yeah, this is what I was looking for. So this is a homework, but these are actually really good test questions. All right, find the values of M in A and B such that the 2 vectors are parallel. All right. So from our previous problem, I mentioned you set each component equal. So you'd set 2M equals 1, 1 equals 8M. Thank you.
Right.
And 3 equals 6. And you're trying to like look for some pattern here, which I'm not seeing.
Right.
So like I'm looking at like a they got to be multiples of each other. So I'm looking at like m equals 1/2. That doesn't seem right.
Yeah.
Let me look at this again. 2m. Oh, no, I'm sorry. If they're parallel, not perpendicular. Okay, that's part B. Part B is easier because you just take the dot product and solve for m. Okay, so yeah, this doesn't work. Parallel. 1 equals 8m. M is 1/8, 1/2. That's not right. 2m. Okay, let's go to part B.
Okay.
I don't understand that.
But if that were to work out, you would solve for m, and then you would see if they're scalar multiples of each other.
Yes, exactly. I mean, that's the idea, is it's that 2m times k equals 1 and 1 times k equals 8m. So if we solve for k equals 1 over 2m, and the second one, k equals 8m. So solving here, you get 16m squared equals 1. So m equals plus or minus the square root of 1 over 16, which is plus or minus 1/4. Which probably is right now that I'm looking at it again. So let's do that. So we've got that here. Let me get rid of this. So let's let m equal 1/4. So you have 2 times 1/4 plus j plus 3k. So that leads to 1/2 I plus j plus 3k. And then your other vector, it's I plus 2k plus 6k. Yeah, that works, because if you multiply this first one by 2, that gets you to
Right.
the second one. And then the negative just changes the sign of a couple of places. So I take that back. I guess this is doable. You do set, probably this on the right is better, not what I wrote here first.
Yeah.
It's something times k equals that, something times k, and then you solve both of them for k.
Okay. And what were you talking about? Negative. What about a negative number?
Yeah, so it both works. So if we let m equal negative 1/4,
Oh,
all that it does is change the signs here. It goes 2 times negative 1/4 I
but they're
plus
also
j.
parallel.
Yeah, because
Okay.
it's just the one that's changing.
Okay.
Plus j plus 3k. And then this one became I hat minus 2 j hat plus 6k hat.
All right.
All right. So now now we care about them being perpendicular. And it's just so easy to just forget, like, what does that mean? In this case, the dot product is 0. Perpendicular 90 degrees, that might help. So it's 2m I hat plus j hat plus 3k hat. And then I like to put them vertical to help with sort of organizing this. So it's 2m plus 8m plus 18 equals 0. And then you solve for m. So whatever, 10m equals minus
So
18.
dot product in general, would it pretty much tells you if it's parallel, perpendicular.
It can.
No,
No, you can tell you if they're perpendicular. The parallel doesn't help you at all.
okay.
Just the
'cause it's
perpendicular.
right. Okay. And with finding the angle between them, does that?
Yeah. Well,
It's positive. It's cute.
it's used for that. And we're gonna see that in the next problem here, because this is kind of the like exam-y question, angle between question.
Right.
So they say find the exact value of C such that the angle between CJ plus K, J plus K. So notice they don't always give you I.
Yeah.
They can give you just two of those. So they're telling you that theta is 60. They're telling you cosine of theta, which is U dot W over magnitude of U, magnitude of W, but they're telling you it's 60. And what's cosine of 60? You know, you want to make sure you remember that it's 1/2. Okay. Now the dot product is C times J times J. So it's C 1 times 1. So it's C plus 1 in the numerator over. And then in the denominator, you get the magnitude of U. So that's C squared plus 1 squared square rooted times W 1 squared plus 1 squared. So all of this leads to 1/2 equals C plus 1 over square root C squared plus 1 times the square root of 2. And you can solve for C in this one. We don't want to do that.
Okay.
I think this one's so. But let's go to the next one here. Or any questions on that? Sorry.
No, I get it.
So what I envision though is you getting a problem where the right hand side becomes something like cosine theta equals square root of 2 over 2, or like 1 over the square root of 2.
Yeah.
And you're supposed to remember, oh yeah, that's 45 degrees. So look at your unit circle.
Okay.
And as you know, before you
Okay.
remember some stuff. Okay, next question. Find a vector of length 5 that is perpendicular to both I plus j and I minus 2j plus k. So to be perpendicular, when you're given two vectors, that's cross product. Okay, so you got your I, your j, and your k, and you got 1, 1, 0, 1, minus 2, 1. Okay, take the determinant of that. So that gives you in the I direction, so 1 minus 0 minus j hat. That's also 1 minus 0 plus k hat minus 2 minus 1. So that gives you, what does that give you? It gives you I minus j minus 3k. So that's the perpendicular, but its magnitude, we don't know what its magnitude is. Maybe it is 5. Maybe it is 5. We got to find out. So the magnitude of this thing is 1 squared plus minus 1 squared plus minus 3 squared square rooted. Okay, so that's square root of 11, which is not 5.
Right.
Okay, so it's like you need to multiply this vector by something so that its magnitude becomes 5.
Okay.
And so the kind of the shortcut is it's 5 over the square root of 11, because you already have that. You have to take this and multiply it by I, or the 1 comma negative 1 comma negative 3. Because the magnitude of this thing inside the angle brackets is square root of 11.
Mm-hmm.
So dividing it by square root of 11 gets you to 5.
Would it be like square root, for example, like square root of 11 x equals 5?
You'd multiply, yeah, you'd multiply each of these by, you'd multiply each of these in.
Okay. Okay.
All right. Yeah, so let me do this.